I'm Doug Waters with HarvestMaster. Today we are going to showcase our Alvo Field Applicator control system, run through a little bit of a few of the use cases and the user interface, how it can improve application, whether it's sprayer or in-furrow liquid for your research program.
Hey everyone, it's Ryan Moses here with HarvestMaster, and I'll be helping Doug go through some of these slides and help with some of the explanations.
So we'll jump right into our software. For those of you familiar with Mirus, this is the home screen. It's where we start with each product, each plugin. We can see on the bottom of this screen, we're connected to the sprayer and the GNSS attachment, the two required plugins to make things happen in the field. With Alvo, we're able to tie each product to each plot. We're able to completely automate the whole pass throughout the field, the whole trial. We're storing GPS coordinates for each plot and which product was applied, time stamped. We can load our map, whether it's a generic CSV or an export from ARM, right into Mirus. We have no possibility of error tying the wrong product to the wrong plot. We can control any 12-volt solenoid, whether it's electric, air, or hydraulic, to activate each treatment. We can control up to 3 treatments per plot per module.
All right, here's a really good example of using the Alvo plugin for liquid application on planters. You can see in this picture, it's kind of hard to tell, but this one is controlling up to 24 different products in some of those cans and treatment tanks on this system. It's pretty easy to install this in about a day and do the calibration as well. Like Doug mentioned, we're compatible with most 12-volt solenoids. You can see down at the bottom around the row unit, you can see this one has actually a 2x2 application and then in furrow. And then at the rear of the row unit, you can see there's kind of a dribble on top of the furrow that we're doing there for that application.
This is the same system on a 24 boom sprayer. Customer designed, and we tied right into their electric solenoids mounted back behind the enclosure. And we're able, again, to fire up to 3 different products per module per plot. This is also a 24 product system. Again, like Ryan mentioned, this is about a day installation, compatible with most any 12-volt solenoid up to 20 watts. This is a picture of the internals of the Alvo system. These are the 3 control modules that control each product for each boom. In the center of the picture, we can see the individual flow meters that monitor the application of each product to each boom. In the center of this picture is the pressure transducer that monitors the regulated tank pressure for the sprayer system. The following slides are pictures of an installation of an Alvo system on a precision planter. This is an 8-product system applying in 3 different application points. This user is applying 3 products in furrow, 3 products that are 2x2 side placement, and 2 products as a dribble behind the press wheels. Note the various colors of tubing indicating the different products. It's real easy to see here the multiple application points, the multiple products required for these trials, and how Alvo can make this easier and automate the entire process.
Okay, here's a good view of the screen of Mirus and the Alvo plugin, kind of the user interface that you can see. And if you guys are familiar with Mirus, you can tell that this is kind of our same quad view. Got one of the quadrants here shrunk down to get a better view on that left side of the actual field or the plot view of going through the system. You'll notice that green arrow, that's your actual GPS receiver. And this black and white bar, that would be your toolbar or application of the system.
And the big benefit with the field view is we're able to paint coverage, so we can see which plots were applied. In the case where a trial has more treatments than what the sprayer is capable of handling, say it's a 20 treatment trial, we only have a 16 boom sprayer, we're able to apply the first 16 treatments. We will show the plots that didn't have the active treatment would stay green. We're able to reload our remaining 4 treatments, drive the trial again to show complete coverage. Also on this screen, we can see that the first 2 plots 1-1 and 2-1, both have 3 different products applying simultaneously. We're able to do that with the software in the export, whether it's directly out of ARM or a built CSV. We're able to add more than 1 product per row.
Yeah, and you can see in the top right quadrant there the actual boom actuations going on and off visually. And then in that bottom right quadrant, you can see the actual treatment numbers that we're applying, like I mentioned.
We'll start just with a live demonstration of the software now. Okay. This is the home screen of Mirus. When we are ready to apply a trial, once we've uploaded the maps, we're able to go in, select maps, find the trial we want to apply, and run through the setup. We work right to left in this screen, click Applicator Setup, and then in the treatment identifier box, we will have every column that is in the Excel export or import. If this is an ARM import, we'll have each column will show up here. We just need to choose the correct column that has the treatment identifier, whether it's name, product name, chemistry, treatment number. In this case, we'll use treatment number. Select that, and then it drops all of the treatments in numerical order throughout each product. This is a 16 boom system. We have each product aligned. If we need to make changes in this, it's easily doable. We'll select that product. If we want treatment 4 on a separate boom, push it over to the other side, and we'll just switch boom 6. So those over, we'll bring treatment 4 back to boom 6, treatment 8 on boom 2. Once we've verified that treatment 3 is physically connected to boom 1, treatment 8 is physically connected to boom 2, and so on, we'll hit the check mark. This tells Mirus which product is on which boom. We'll proceed out to our trial, then we'll establish our AB line. Use a new AB line, enter our plot dimensions. Right now we use a 1.5 foot alley, a 20-foot plot. We're doing 6 30-inch rows, 15-foot effective swath. This is where we'll pull up. We'll position boom 1 directly at the start of the plot. Capture the A point. Hit the arrow to save it, and then right now we're able to either drive down and capture a B point or enter a heading. What's important to remember here is this creates all of the trip points perpendicular to the heading we enter here, whether it's manually entered or calculated with a B point. We will manually enter a 0 heading, true north, and that generates the entire trial. We see here that we're positioned right over the start of plot 1-1, proceeding in a 0-degree heading, and all of the plots are laid out based on that. 10 ranges deep, 5 plots wide, and we are right at the beginning of 1-1. Once this procedure is complete, we will back out of the trial, check mark, and at this point we are ready to apply. For those familiar with Mirus, this is the same navigation screen we see in Harvest. We'll run a serpentine pattern starting from left to right, going up range. Green arrow always indicates travel within the range. We're starting at range 1, row 1, lower left corner. We'll arrow through the notes screen. We will run in automatic mode. Our target drive speed is 2.5 miles per hour. And we are to our run screen. From this point, we hit the start button, and we're ready to start travel within the plots. And you'll see as we pull into the plot, treatment 1 will apply. Which is boom 15. As we travel through the trial, we can look at our flow rate, application rate, system pressure, application time, and the active treatment. In the event of an issue within the row of the trial, we'll also have the feature to pause the system. And in this case, I paused it right at the start of range 8, but it allowed us to finish range 8. If there is a non-emergency situation, we're able to finish the application of that plot and not trip going into the next plot. This is a big advantage if there's a perceived issue or if there's a possibility of a plug nozzle, but the user isn't completely certain what the problem is. We won't have to stop in the middle of that trial or middle of that plot and lose that plot. And again, we can verify that data with the export. Resuming is easy. We back into the previous plot. Check our navigation. We are navigating into plot 9-1, going up range. We will resume tripping and drive into range 9, and we will apply in range 9. That one's over target. There, now we can see right here, and if I pause it, it stops, but right here, we're showing, and I guess this would be a good one. We have different targets for each boom. So we can see boom 3 is over target, boom 4 is at target, it's green. Air pressure above is also green, but we have the ability within the software to identify an upper and a lower limit for each boom. When we're within that limit, such as we are right now, each bar shows green. We're targeting about 16.7 gallons per acre. And this is all calculated off of plot width and travel speed. Again, we're right within target. If the user were to speed up or slow down to come outside of the range, such as we did right here, we're under target, we're driving too fast. This is logged in the export, so we're able to see that we missed target on that particular plot. Again here. Within the setup screen, we're able to set upper and lower limits for each boom in flow and for the air pressure sensor. We included an air pressure sensor with the Alvo flow kit, so we're able to monitor regulated air pressure, which would be what is going to the pressurized canisters, 2-liter bottles with headers, however the sprayer is configured. We're able to monitor that, log that at 5 hertz. We're getting 5 readings every second that is stored within the export file to verify that we maintain correct tank pressure and correct flow rate during application. I had this one set up as our lower threshold at 55, upper threshold at 65, and then in this screenshot, we can see that we're showing right at 60 pounds. We're within that range. Green is go. We're also able to adjust our calibration coefficient for each sensor independently if we're using a different density of a liquid, whether it's liquid fertilizer that's more dense. If we need to make an adjustment to correctly calibrate the flow meter, we're able to do that within the Mirus setup. A little farther down, which shows we're able to set a lower and upper limit for application rate that we see in the screenshot. I have the lower limit set at 15 gallons per acre. The upper limit is set at 20. Whenever we deviate from that range, the bar will turn red that we're over rate, yellow if we're under rate. Those, again, are configurable per boom if there are different application rates across the sprayer. We can see here, boom 1 is within our 15 to 20 gallon user-defined limits for that particular product. We're running 4 miles per hour on an 8-foot plot, applying 15.65 gallons per acre. Farther down in this screen, we're able to look at flow rates. So we're flowing 1.012 gallons per minute through that sensor. That's total flow for the entire boom, or total flow for the entire planter if this is an in-furrow or dribble application. What we see here is an export generated by Mirus after we ran a trial. We're time stamped. We show which range, which row, and the cycle. We're logging data at 5 hertz. So we're getting 5 data points every second throughout the whole trial. We can see here lines 1 through 37 is all plot 1-1. We can see our system pressure maintained right along the target, slight variation. And this particular plot was using boom 1. We can see our application rate in gallons per acre and our flow rate in gallons per minute are logged through the entire plot. What's interesting with this trial is I tested this to prove what happens when something goes wrong within a trial. And this was a great example. I did not prime the system past the electric actuators. There was air in the boom all the way out, and this is a 4-nozzle boom. So I wanted to see what happened when a user forgot to prime, get the system ready to apply. And we can see right here, the first 3 data points of that plot varied as we're due to pushing air past the flow meter and out to the nozzles. This is a great tool to verify application throughout a plot to make sure we hit our target rate throughout the entire plot rather than just in the center. We can see it again in range 6, same situation. That was the first time that product was used, and it took a second, close to a second, for flow to stabilize. So we know by looking at this export, we have an issue with the first treatment, or the first application of each treatment. And this is all data that's stored. We can go back and reference it. When the user or the researcher is taking notes on that particular plot, we can say, we had an issue. The first 5 feet of this plot, we had a misapplication. We're also able to see this if we have a blocked nozzle or a blocked orifice plate. Theoretically, it should, in a 4-nozzle boom, we should reduce flow or 25%. We should only see 75% of the flow, and we're able to do that too. That concludes today's presentation on the HarvestMaster Alvo system. I'd like to thank everybody for taking the time to watch this. And as always, if you have any questions, please contact a HarvestMaster representative or go to our website, www.harvestmaster.com. Thank you very much and have a great day.